Right, this is the last video for Module 13. We've talked a lot of information about atoms and strong force and weak force and radioactivity, beta particles, alpha particles, gamma particles. A lot of information in this chapter. This last little section is on radioactive dating. Now, this isn't dating radioactive isotopes, going out to the movies and on to dinner with them, not that type of dating. It's probably something you've actually heard about quite a bit when they have something that is very old and they're trying to put a date to it and say when that item was existing. Then we would use radioactive dating. So because isotopes do decay at measurable rates, they will take samples of the object and measure the isotopes in it to put a date to it and kind of reverse half-life it to find out how old the object is. So the best one that is known that gets used a lot is carbon-14 dating. Anything that used to be alive can be dated by carbon-14 to an extent. So when they find, let's say, a bone that has been buried of a dinosaur, they will use carbon-14 dating to try to determine when that dinosaur lived. Now, carbon-14 decays by beta decay, and the half-life is 5,700 years. All right. So all living organisms contain carbon-14, like I said yesterday, and then they're continually exchanging it with their environment. So the amount that you have is dependent on when you lived, right? So when that organism dies, the exchange ceases, and so then that carbon-14 is going to decay away. Now, you have to know how much you have to start with in order to calculate your age. So you could say that you have this much and then start working backward, but if you don't know when to stop, then you don't know when to stop aging it. And a lot of this information is based on assumptions. They base it on the assumption of when something was alive to determine how much it had to begin with. They base that on how much carbon-14 is in the atmosphere, but there are a lot of things that happen on the planet that can change the amount of carbon-14 that is in the atmosphere. And so, like after they had the atomic bomb, the amount of carbon-14 in the atmosphere increased significantly. Okay, and so when we use tree rings, which we talked about in 7th grade science, dendrochronology, to date things, we can see that the levels of carbon-14 are not consistent even over the last 3,000 years, which is where we have fairly consistent dendrochronology data. So we can see that using that starts you off with an assumption of something that we don't know for sure. If you don't know how much you had, you can't say how much was lost. So that would be like saying that you lost your wallet and then when you got it back you had $5 in it. We could say, oh, someone stole money from you, but if we don't know how much you had to begin with, we don't know how much money was taken, if any was taken at all. Because what if it was an empty wallet and they put in $5? So we would actually say that with all of the radioactive dating techniques, they're not very accurate at all. In fact, the only ones that can be measured fairly accurately are definitely under 3,000 years old. We can compare that data to data that's in the tree rings that we have to see how much carbon was in the atmosphere during those times to be able to tell when something lived. So anytime that they give you a date of an item that is over 3,000 years old, when they say, oh, this bone was from 14 million years ago, please view it skeptically and don't just buy into it. Because the assumption is how much it had initially. That could be very inaccurate. There is no backup data to that. That is one person saying one thing without any backup data to say how much carbon-14 was in the air when that organism stopped living. So all types of radioactive dating suffer from this inaccuracy because we also make the assumption that half-lives remain consistent. That they haven't changed over time with different things changing in our environment as well. Click on the link and complete the quiz, and I'll see you in class.